All right, geometry. We are moving on to the next section here, 4.5, which is talking about a few more ways to prove that triangles are congruent. We have two: angle, side, angle, 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 side, and the last one is HL, which means hypotenuse leg. Hypotenuse leg specifically deals with right triangles, okay? So this first one, angle, side, angle, it's exactly what it sounds like. You have an angle congruent to an angle. You've got a side congruent to a side, and then another angle congruent to another angle. So the order goes A, S, A. Okay, so two angles and the included side of a triangle make the triangles congruent. Okay, so again, that's something you probably want to make sure you have written down as one of the triangle congruent theorems. Okay, so in this case, we have if angle A is congruent to angle D, we have AB is congruent to DE, and angle B is congruent to angle E. If that's all true, angle side angle says that the triangles are congruent. So ABC congruent to triangle DEF. Okay. So let's look at another proof here. So take a look at your picture right away. Without even looking at any of this, I can see right away QS is the same in both. So I know eventually I'm going to use QS with reflexive. But look what it says. SQ bisects both of these angles. Okay, RQT is this angle, and RST is this angle. Okay, so if they're both bisected, that means the two angles they split into are congruent. Okay, so that's a given. And then RQS and TQS. RQS is this one, TQS is this one. And I know those are congruent because the definition of angle bisector. Okay. And then it says RSQ and TSQ. So RSQ is this angle here, and TSQ is this angle here. So those two are also congruent by the same definition, angle bisector. Okay. And then the last thing, I've got angle and an angle, and now we need a side, and it just so happens that we have the side between those two angles. So if you look at the top triangle, it goes angle, side, angle in that order. And that is QS congruent to QS because of the reflexive property. Okay. And so we have QRS congruent to QST because of angle, side, angle. And that's it. Okay. So what I'm going to do is leave you to this one. I want you to try number 2. So if you need to pause it to take a look at that. Oh, actually, we're going to do that one together. Sorry. We're going to do this one together. So this one has to do with some parallel lines. As you can see in our given, we have some parallel line situations. Okay, so JK and LM. JK is parallel to LM. And as you can see, this is your transversal. Okay, so what we have here, this is something we learned last chapter. Parallel lines create angles that are congruent. So if you can look at this, these two angles, if these are the parallel lines, they're on the interior, right? And they're alternate interior angles. So JKL and MLK are congruent by alternate interior angles. Okay. And using that same transversal, we have JL is parallel to KM. So in the same way, here's the two lines that are parallel. So the alternate interior situation is going to be here and here. Those two angles are also congruent by alternate interior angles. Okay. And then finally, we're looking at the kind of the same situation here. If you look at this pair of angles, this line in the middle is the same for both triangles. So KL congruent to KL by reflexive. And now look at the top triangle here. ASA. So angle, side, angle. All right. Okay. So I'm going to leave this one to you. So go ahead and pause the video if you want to go ahead and write down the given and what you're trying to prove. Okay. So pause it, write that down, and then go on. So the next one, angle, side, angle side just means the order is different. So we've got angle, angle, and then side, or side, angle, angle. Okay. So A next to each other, and then S. A, and S. So in this case, if angle A is congruent to angle D, and then we also have angle B congruent to angle E. And then the next side is BC congruent to EF. If you've got angle, angle, side, then you can say the triangles are therefore congruent. Okay. So let's look at angle, angle, side proof. So again, looking at this picture, I know right away the side is probably going to most likely be YZ congruent to itself. Okay, so I'll just keep that in mind before I go. But now look at what our given tells us. Okay, so I'm going to write down the given first. So YZ bisects angle WYX. Okay, so let's go ahead and use that. Okay, actually I'll write down the second given as well. WYZ congruent to YXZ. Sorry, I said that wrong. YWZ, YXZ. So YWZ congruent to YXZ. So there's one angle. Got A. And then both of those are given. Now, I have not used this given yet, so now we're going to use it. Okay, so YZ bisects WYX. So WYX is this whole angle up here. So that bisector splits it up into these two angles. Okay, so that first angle on the left is WYZ, angle WYZ, congruent to the right angle, which is angle XYZ. Those are congruent because of the definition of angle bisector. So I used the first given, which was a bisector, angle bisector. All right, and so right now I have angle, I've got an angle, and now finish it out with the side. So YZ congruent to YZ, and that is reflexive property. Okay, so now I've got AAS, and I can go ahead and call the triangles congruent. So look at your congruency statement. WYZ triangle is congruent to triangle XYZ, and that is by angle, angle, side. Okay. So, once again, I'm going to go ahead and let you, we can probably try one of these together. Yeah, so I'll let you do number 6, but let's do number 5 together real quick. So again, I'm going to write down my givens. Angle ABC, congruent to angle CED. That's a given. So I'm going to go ahead and label that ABC, CED. So I've got A so far, angle. So the second one says AB is parallel to CE, given. And the last given says C is the midpoint of AD, also a given. So now let's use the two givens we haven't used yet. So I already used the first given. The second given, AB is parallel to CE. AB, right there, parallel to CE. Now, if you look at these two, they are connected by this transversal, okay? If they're connected by that transversal, look at the angles that they share. Right here, angle A and angle C. So those two angles are congruent because what kind of angles are they? They are corresponding angles. Okay, so angle BAC is congruent to angle ECD because of corresponding angles. Okay, so when it says parallel in the given, you're going to use one of your parallel relationships that we talked about last chapter. Okay, so now let's use the second given. Okay, I used this given. Done with that one. Now let's use the last one. So C is the midpoint of AD. So if C is the midpoint of this whole segment, that means it splits it up into two congruent parts. So I've got A, and then the last one's going to be S. So AC is congruent to CD. That is by definition of a midpoint. And so triangle ABC is congruent to triangle CED by angle, side. Okay? And so I'm going to have you try this one. Just go ahead and write that one down. Make sure you can see that. Pause it if you need to get that written down. And then we're going to look at the last one here, which is right triangle congruence, hypotenuse leg. So hypotenuse leg is used in right triangles only because the hypotenuse is the one opposite of the right angle. Okay, so this is the only time we can have angle, side, side, because we don't cuss in math class, so we don't write ASS. So what we do is say we've got a right angle and we've got hypotenuse and leg congruent, the leg being one of the angles on the side. Okay, so in this case the hypotenuse would be BC congruent to EF. The leg in this case would be AB congruent to DE. And since they're both right angles, we can now say the triangles ABC congruent to triangle DEF. We can say they're congruent. Okay, so if the hypotenuse and a leg of a right triangle are congruent to another of the same, then they are congruent. Okay? And so we can try this next proof. So on this one, we've got obviously two right angles. So right away, I'm seeing MP and MP going to be congruent. I already have the right angle. So now I just need the hypotenuse to be congruent and a leg, which MP and MP is going to be my leg. So let's see what we're given. Said they're right triangles, so check, that's given. ML is congruent to MN, so that's the one I marked. So that is given as well. So I've used that. MP congruent to MP, again, that is reflexive. And so now that I have H and L, we are good to go. Hypotenuse leg. Easy as that. So I want you to go ahead and try this one. Says WVX are right triangles, where I think since V is the middle and Z is the middle, these are your right angles. So you have to prove these are congruent triangles based on the hypotenuse and the leg. So use your given and then fill in the rest of the proof to get your answer. Okay, so pause the video if you need to, get that written down, and then try those 3 problems out. Okay, go back and look at the problems if you need to. Go back and pause and write those down. And then we'll talk about those in a video tomorrow or today if we can. All right. Good luck. Peace.